Hey guys, welcome to part 5 in this Bitcoin Cash wallet tutorial. In this video we will be implementing the getBalance function that we have defined previously on our wallet module. By the end of this video we will be able to perform a full deposit flow and we'll be finally able to add some funds on our wallet and see the balance show up in our UI. So that's it for the intro and let's jump right into it. So first I'm going to open where we left off on the previous video. We implemented our wallet's private key import and export process. Now, if we look here on line 24 of the code that we're left with, our balance is not really being computed. We're just returning a string in the function getBalance, which says getBalance. And therefore, when we refresh our page on our wallet, we can see a balance of getBalance Satoshis. Now, since we already have our deposit address available to us, we can move forward into implementing the real getBalance function. So for doing this and on the next video as well, we're going to be using a development tool developed by the website bitcoin.com. If you go to developer.bitcoin.com, you're going to find a lot of very useful resources for developing in the Bitcoin Cash network. And in particular, today we're going to be using what is called the REST API, which is essentially just a platform for getting information out of a public node, which is provided by bitcoin.com. Now, this is necessary in order for our wallet to interact with the real world. In this case, we're just going to be retrieving the balance, but in the next video, we're actually going to be using some more requests on this API. So, if we look here at the specification for this API, we can see that there's a lot of very useful things for different blockchain objects. For example, first of all, we have the address endpoints. For example, address details, address UTXO. We also have a endpoint for getting information about a block. We also have an endpoint for getting general information about the blockchain, like for example, what is the current number of blocks that exist in the network. There's a whole bunch of other things we're going to be seeing on the next video as well. The raw transactions endpoint to actually broadcast transactions to the network. But for today, we're only going to be using the most basic endpoint, which is just getting details about a given address. If we click here on this request, we can see a definition of the arguments that the request expects and the form of the response. Now, there's also a very handy try it out feature here. Now, if I click here and I click on execute, here we can see exactly what is the request that is being executed, and as well we get the full response body for a real address. Now, if we look more carefully within the response body, we can see there's a lot of interesting details, like for example, the balance, which we'll be using today. And there's other things like, for example, the transactions where this address is involved. Now, just to start off testing this out, I'm just going to copy this request exactly as it's created by the API tester. And I'm going to put this here into the getBalance function. For actually fetching data across the network, we're going to be using this function fetch, which we added on our first video. And I'm just going to put the full endpoint with the address that's provided here. And as a result, the fetch function performs a request to the network. And what it returns is actually a promise. Now, whenever you're dealing with promises, this essentially means there's some asynchronous code happening behind the scenes, but it's really easy to handle this asynchronism by essentially just adding a function which is to be executed on the result of the promise. So in this case, the function fetch to the address details is going to return a response. Now, by this point, we're not really sure whether the request itself completed successfully. It may have failed for different reasons, like, for example, being malformed if we make a mistake when doing the request, or it may just fail for random network problems, like, for example, if you don't have an internet connection. So the first thing that we're going to do here is we're going to check if the response is actually okay. We're going to say if it is not okay, we're going to just throw an error saying fetching balance failed. Please try again later. Otherwise, if the response is successful, and since we're expecting a JSON response, we can simply return res.json. So res.json also returns a promise, which the result of which is going to be the actual JSON object. So in order to actually process that data, I'm going to put another then statement here, and I'm going to add a function which, given the address details, the first thing I'm going to do is just console log these details to see that everything is actually going just fine. I'm going to refresh the page where we left off. Now, if we look here into the console, we can see that we're actually getting the same details that the API was providing for us. For example, the balance on this address is 2 cents of Bitcoin Cash, which is exactly what we were getting here. Now, of course, this data that we're getting here doesn't belong to our own deposit address, but just to the address which came as an example on our REST API tester. So what we're actually going to do here is change the address which is provided as part of the request, and we're going to add our own deposit address. Now, if I refresh the page, we're getting the details, but for our own deposit address in this case, and we can see we have a balance of 0, which makes sense because we haven't done any transactions on this address yet. Another thing you can notice here is where it used to say get balance satoshis, now we're printing object promise satoshis. Now the reason for this has to do with the code that we wrote originally on index.js. If we take a look here, what we're actually doing is putting into the inner text of the balance display the result of the wallet.getBalance function. However, this function returns a promise. It doesn't return the actual balance yet. So what you need to do is to the result of this promise, once it has finished executing, at this point we're going to have a balance, and we're going to put as the inner text of our balance display, we're going to put the actual balance. We also need to handle the case when the network request fails for some reason, and the way we do this is we add a catch statement here which says given an error, what I'm going to do is I'm just going to alert the error itself. In order to actually display the error, I'm going to do the error.message. Sometimes an error might not have a message, so I'm just going to put error.title, and if it doesn't have a title either, we're just going to add here a string saying unexpected error. However, this is not fully complete yet. If we refresh the page, we're going to see an undefined coming here. Now, the reason for this is because, let's take a look again on our getBalance function. Here we're just console logging the details, but we're not actually returning anything at the end of this function. So what we actually want to do here is compute the details on compute the balance from the details. So this is really easy because the details itself already contains the actual balance as we've seen before. In fact, it contains two objects, two properties. One is balance, which is denominated in Bitcoin Cash. However, we're going to use the balance set, which is the same amount but expressed in Satoshis. Now if I refresh the page, we get 0 Satoshis. Now that makes sense because our wallet is empty. However, there's one more thing we need to add there, which is just by looking again into the REST API, we also have this other property called unconfirmed balance and unconfirmed balance Satoshis. Now the difference between balance and unconfirmed balance is balance only sums up all the funds that the address has received in transactions that are already part of the blockchain. That means they have already been mined into a block by a miner. However, we want our wallet to be more to essentially react to events before they actually make it into the blockchain. This is usually called accepting zero-conf transactions or instant transactions. So in our case, we also want to sum the unconfirmed balance of our address to display not only the result of those transactions that have already been added to the blockchain, but also those that have just been broadcasted and are yet to be mined. So I'm going to add this here. Now if I refresh the page, again I get 0 Satoshis, which is perfectly fine because we haven't sent any money. But at this point we already have a valid deposit address which corresponds to our private key, and that means that if we send money to this address, we're going to see it showing up here in the balance. So I'm going to send just a few Satoshis to actually complete a full deposit flow. I have another wallet here with a few Satoshis already in it so that we can try it. That went okay, and now if I refresh our wallet, there we have it, 10,000 Satoshis. So we've just completed our first deposit flow, and we're already able to essentially add funds to our wallet. This is real money sent over the real Bitcoin Cash network. And the next step we're going to be doing is to be able to actually withdraw this money or spend it essentially. So that's it for this video, and see you again on part number 6.